In a single day, this storm gained 50 knots of wind. That is not strengthening. That is an explosion. In about 48 hours, a modest tropical system in the western Pacific became a Category 4 typhoon, and forecasters say it is still climbing towards super typhoon strength. It is the most powerful June typhoon this part of the world has seen in 22 years, and right now it is turning toward the islands of southern Japan. Here's exactly how it happened, where it is headed, and what the next 48 hours hold. The western North Pacific just produced its most powerful June typhoon in 22 years, and it did it in about 2 days. The storm is named Mekkhala on the international list. When it crossed into the zone the Philippine Weather Agency watches on Friday, the agency gave it the local name Francisco. To the forecasters tracking it, it carries the basin label 07W. Whatever you call it, the facts are the same. As of yesterday, it had gone from a modest, disorganized tropical system to a high-end typhoon at Category 4 strength. And the forecasters at the Joint Typhoon Warning Center were calling for it to climb to super typhoon intensity. Here is the part that stops you. The last time a June typhoon in this part of the world reached this kind of strength was the year 2004. That is more than 2 decades without a June storm this violent. The peak of the Western Pacific typhoon season does not even arrive until late summer and autumn, when the ocean has had months to soak up heat. Mekkhala showed up a full season early, blew past the textbook definition of a dangerous storm, and is now curving toward land. Right now, the storm is sitting in the Philippine Sea, east of the northern Philippine island of Luzon. And the good news, if there is good news in this, is that it is not driving straight into Luzon. It is turning north. That turn is going to carry it across open water toward the southern islands of Japan, and that is where the danger is now pointed. Let me give you the number that defines this storm, because it is the whole story in one statistic. Beginning on Monday, Mekkhala underwent what meteorologists call rapid intensification. There is a formal definition for that. A storm has to gain at least 30 knots of maximum sustained wind in 24 hours to qualify. 30 knots in a day is the bar. Mekkhala gained roughly 50 knots in 24 hours. Over a 36-hour stretch, it picked up about 70 knots. It did not just clear the bar for rapid intensification. It cleared it so completely that forecasters reach for a different word for this. They call it explosive intensification, and it sits at the far upper edge of what these storms are capable of doing. Think about what that means on the ground. A storm that strengthens this fast gives everyone less time. Less time for forecasters to nail down where it is going. Less time for islands in its path to move boats, secure homes, and stock up. Storms that bloom this quickly have a long history of being the ones that cause the most damage when they finally reach people, precisely because the window to get ready slams shut so fast. A system that looked unremarkable at the start of the week was, by yesterday, a Category 4. And this is what makes rapid intensification so dangerous beyond just the raw wind speed. For decades, forecasters have been far better at predicting where a storm will go than how strong it will get. Track forecasting has improved enormously. Intensity forecasting has lagged behind because the small-scale processes buried inside the core that drive these explosive jumps are genuinely hard to see coming. So when a storm does what Mekkhala did, ballooning dozens of knots in a single day, it is exactly the scenario that catches coastal communities off guard. The forecast issued before the jump can look like a very different, far gentler storm than the one that actually shows up at the coast a day later, and the engine driving that explosion had not run out of fuel. The Joint Typhoon Warning Center forecast that the storm could keep climbing all the way to super typhoon strength, with the door left open to push past even that if the intensification rate held. So how strong is this thing in numbers you can hold on to? At one analyzed fix, Mekkhala was carrying maximum sustained winds near 95 knots. That is roughly 50 meters per second, and the central pressure, which is the truest gauge of a storm's raw power, had fallen to about 935 hectopascals. When the pressure at the center drops like that, it means the storm is pulling air inward and upward harder and harder, and the winds wrapped around the core respond by accelerating. The forecast peak was the part that had everyone watching. The Joint Typhoon Warning Center projected Mekkhala to reach around 130 knots. 130 knots is not an arbitrary figure. It is the exact threshold where a storm earns the label super typhoon. That is the Western Pacific's equivalent of a top-end Category 5 class system in the Atlantic. And the forecasters noted that if the storm kept intensifying at the rate it had been, it could climb even higher than that. To translate that into something concrete, a storm at Category 4 strength carries winds capable of tearing the roofs off well-built homes, snapping or uprooting trees by the thousands, and leaving neighborhoods uninhabitable for weeks. A super typhoon at 130 knots and above is in the category that flattens poorly built structures entirely and turns loose objects into airborne projectiles. These are not abstract numbers on a chart. They are descriptions of what the wind physically does to a place when it arrives, and they are why the difference between a Category 3 and a super typhoon is the difference between a hard storm and a catastrophe. Stack those facts together. You have a storm that did not exist in any threatening form at the start of the week. By yesterday, it was a Category 4 with a central pressure under 940 hectopascals, forecast to become a super typhoon in a month when storms like this are supposed to be nearly impossible. Every piece of that is unusual on its own. Together, they describe one of the most remarkable early season storms the basin has produced in a generation. Now let me tell you where it is going, because this is the part that matters most for the people in its path. Mekkhala is being steered by a large dome of high pressure parked to its northeast, a feature forecasters call the subtropical ridge. Think of that ridge as a wall the storm cannot climb over, so instead the storm slides along the southern and western edge of it, moving west-northwest at about 20 kilometers an hour, until it reaches the western end of that wall, and there it turns. That turn is the single most important thing about this forecast. It is what meteorologists call recurvature, and it is the classic path that sends western Pacific storms north and then northeast, toward Japan, rather than west into the Asian mainland. For Mekkhala, the models carry it across the open Philippine Sea and aim it at the Ryukyu Islands of southern Japan. The closest approach is forecast for Thursday into Friday. The Sakishima Islands and Okinawa's main island are the places flagged for the most direct hit. These are not empty specks of rock. Okinawa alone is home to well over 1 million people. After Okinawa, the models steer the weakening system toward the waters south of Japan in the direction of Tosa Bay on the island of Shikoku. And it is worth being clear about what a close approach actually brings, because a typhoon is far more than its peak wind number. It brings storm surge, the wall of seawater the storm shoves ahead of itself onto the coast. It brings torrential rain measured in hundreds of millimeters, which on steep island terrain turns into flash floods and landslides. And it brings days of dangerous pounding seas for the fishing fleets and shipping lanes that these islands depend on. Even a storm that weakens somewhat before arrival can still deliver every one of those hazards to Okinawa and the Sakishima Islands at once. The peak wind is only the headline. The surge and the rain are very often what does the real harm. Here is the honest part of the forecast. The biggest uncertainty is exactly how sharp and how soon that turn happens. How far west does the storm get before the ridge releases it and lets it curve north? And how much does it weaken over slightly cooler water and rougher upper-level winds before it actually reaches Okinawa? Small differences in that turn translate into very large differences in what the islands actually feel. A track that bends a little earlier and a storm that weakens a little faster is a very different Thursday than one that holds its strength all the way to the islands. That is the question forecasters are working right now. So why did this happen? Why did a storm explode into a Category 4 in June when the calendar says it should not be possible? The answer starts with the water. A tropical cyclone is, at its core, a heat engine. It runs on warm ocean water. There is a rough threshold that the science has long recognized. A typhoon generally needs sea surface temperatures of about 26.5 degrees Celsius to sustain itself. Below that, the engine starves. Above that, it has fuel. The water beneath and ahead of Mekkhala was not at 26.5 degrees. It was running 29 to 30 degrees Celsius. In the units, most of us think in, that is roughly 84 to 86 degrees Fahrenheit. That is bath-warm ocean, several degrees above the bare minimum a storm needs, and it was sitting right in the storm's path. When a system finds water this warm running far below the surface, it is like handing the engine a full tank of high-octane fuel. The storm reached down, pulled up that heat, and converted it into wind and falling pressure at an explosive rate. There is a fuller version of this that the science cares about, and it is not just the temperature at the very surface. What truly fuels a storm is how far down that warmth extends, something oceanographers call ocean heat content. A thin skin of warm water at the top can be churned up and cooled by a passing storm, which slams the brakes on intensification. But when the warm layer runs far down, the storm's own winds cannot stir up cool water from below fast enough to starve it. The reservoir beneath Mekkhala was not just hot at the surface. The warmth ran well down into the water column, and that is exactly what allowed the storm to keep feeding hour after hour without choking itself off on its own upwelling. And this is the detail that ties the whole thing back to why it happened in June. Water that warm, this early in the season, is a fully primed reservoir. It is heat that normally would not be fully loaded into the upper ocean until much later in the year. Mekkhala did not have to wait for the peak of the season because in this corner of the Pacific, the ocean was already ready. Warm water alone does not make a super typhoon. Plenty of storms sit over warm ocean and never organize because something in the atmosphere tears them apart. What made Mekkhala different is that everything above the water lined up in its favor too. The first ingredient is low wind shear. Wind shear is the change in wind speed and direction as you climb up through the atmosphere. When shear is high, it tilts a developing storm and rips the top off it before it can stack into a tight vertical column. Mekkhala had almost none of that working against it. The shear around the storm was low, on the order of 12 to 17 miles an hour, which let the storm build straight up and organize without being knocked off balance. The second ingredient is outflow. For a storm to keep strengthening, the air rising up through its core has to have somewhere to go once it reaches the top. If that exhaust gets blocked, the whole engine backs up and stalls. Mekkhala had a favorable channel in the upper atmosphere that acted exactly like an exhaust system, venting all that rising air away from the top of the storm. With the exhaust wide open, the pressure at the surface could keep falling, and the winds could keep climbing. Put it together, and you have a textbook recipe. Bath-warm water feeding the engine from below, low shear letting the storm stand up straight, and a clean exhaust venting the top. When all three of those align at once, you get exactly what we saw. A storm that intensified about as fast as these systems physically can. There's one more layer to why the ocean was so primed, and it is worth understanding because it points beyond this single storm. The Pacific as a whole has been warming through the spring. You may have heard the terms El Niño and La Niña. They describe whether the Central Pacific is running warmer or cooler than normal, and that state ripples out to influence weather across the planet. Late in 2025, the Pacific was on the cool side, leaning toward La Niña. The index that tracks this stood at minus 0.55. By this spring, it had swung all the way to plus 0.48. That is a move from one side of neutral toward the El Niño threshold in roughly 6 months, with the Central Pacific sea surface temperature climbing to just over 28 degrees Celsius. The timing of that swing matters as much as the direction. A Pacific tipping from its cool phase toward its warm phase tends to redistribute where the hottest water pools and where the atmosphere is most willing to let storms grow tall. The Western Pacific, where Mekkhala formed, is one of the places that ends up holding extraordinary amounts of heat during these transitions. So this storm did not form in an average ocean having an average June. It formed in a basin that had been quietly stacking the deck in favor of exactly this kind of event for months. A warming Pacific changes where and when storms form, and it loads extra heat into the upper ocean, the exact heat that a system like Mekkhala can tap. Now, I want to be careful and honest here, because this is where the science demands discipline. No single storm can be cleanly blamed on that warming trend. Mekkhala is one data point, not a trend line. But it is precisely the kind of event that fits the pattern researchers have been describing for years. Very warm water, loaded early, allowing a storm to reach a strength normally reserved for the peak of the season in a month when it has no business doing so. The storm is a symptom, and the warming Pacific is part of the diagnosis. To really understand why the strongest June typhoon in 22 years is such a remarkable phrase, you have to go back to the last time it happened. The year was 2004, and the storm was Typhoon Dianmu, known in the Philippines as Helen. Dianmu did almost exactly what Mekkhala is doing now. It rapidly intensified in June, climbed to super typhoon strength, and ultimately affected southeastern Japan. At its peak, Dianmu was a monster, with winds estimated as high as 155 to 180 knots, and a central pressure down near 915 hectopascals, and that storm did not arrive in a quiet year. The 2004 Western Pacific season went on to produce 6 super typhoons total, and it still ranks as one of the most intense seasons in the modern record. That is the yardstick. When forecasters say Mekkhala is the strongest June typhoon since 2004, they are reaching back to a storm in a season that the record books remember as exceptional. A gap of 22 years tells you how rare this alignment of warm water and calm air really is. It does not happen most Junes. It does not happen most decades worth of Junes. The last time the basin pulled this off, it was the opening act of one of the busiest, most violent seasons on record. That history is exactly why an early super typhoon makes forecasters sit up. It can be a preview of a basin that is loaded and ready to keep producing, and there is a real reason they watch early season outliers beyond simple record keeping. An intense storm this early is a sign that the ocean has already crossed the thresholds the most violent storms require, and it has crossed them with the hottest, longest stretch of the season still ahead of it. That does not mean every storm that follows will be a monster. The atmosphere still has to cooperate each time, with the low shear and the open exhaust lining up all over again, But it does mean the fuel is in place earlier than usual, and that the ceiling on what this season can ultimately produce may be higher than it would be in a normal year. There is a detail in the data that sharpens the whole picture, and it is the contrast between two oceans on the very same day. While Mekkhala was exploding into a near super typhoon, it was not even alone in its own basin. A second tropical system was spinning at the same time. Designated 08W and named Higos, it was far weaker, but it was strong enough to prompt a tropical storm warning for the western waters of Tinian and Saipan in the Mariana Islands, with tropical storm force winds gusting to 50 knots. The Western Pacific was running two named storms at once in late June. Now, look at the other side of the world. On that same calendar day, the Atlantic basin was dead. The National Hurricane Center expected no tropical storm to form anywhere in the Atlantic over the following week, and an enormous plume of dry, dust-laden Saharan air was pushing west into Florida, actively choking off the thunderstorms that tropical systems need to get started. One ocean was manufacturing a near super typhoon and a second storm beside it. The other ocean could not get anything going at all. Two basins on the same planet, on the same day, behaving in completely opposite ways. It is a vivid illustration of just how primed and loaded the Western Pacific has become this year. Whenever a storm this powerful takes aim at land, a familiar set of claims starts circulating online. That the storm is being steered on purpose, that it is being strengthened by some weather modification program, that the agencies are secretly hiding its true power. I want to address these directly because the honest thing to do is take the curiosity seriously and then show you where the physics actually stands. There is no technology on Earth capable of creating, steering, or intensifying a typhoon, and the reason is simply the scale of the energy involved. A mature tropical cyclone releases energy on the order of a large fraction of all the electricity the entire world generates, and it does that every single second. Nothing humans have built operates within orders of magnitude of that. The storm's track is set by the steering flow around it, in this case, that subtropical ridge to the northeast. Its strength is set by ocean heat, wind shear, and outflow. The turn toward Japan is not a mystery, and it is not a plot. It is exactly what the ridge geometry predicts, and it is exactly what this basin does dozens of times every year. As for the idea that someone is hiding the real numbers, that one runs into the opposite problem. Mekkhala is being tracked at the same time by multiple independent agencies in different countries, whose estimates are public and constantly cross-checked against each other. The honest scientific point is that intensity estimates do carry real uncertainty, because they lean heavily on satellite analysis. But that uncertainty is openly disclosed, and it cuts both ways. It is the opposite of a cover-up. So where does this leave us, and what should you actually be watching over the next couple of days? The answer comes down to that turn. The closest approach to Okinawa and the Sakishima Islands is set for Thursday into Friday. The two questions that decide everything are how much the storm weakens before it gets there and how sharply it curves. Slightly cooler water and rougher upper-level winds are expected to take some of the edge off Mekkhala before it reaches the islands, but a Category 4 has a great deal of strength to give up before it becomes harmless. For the people on those islands, this is a serious storm, and the next 48 hours are the window that matters. For everyone watching from farther away, the lesson is bigger than one storm hitting one chain of islands. The Pacific manufactured a record-strength typhoon a full season ahead of schedule, blew it up faster than the textbooks call ordinary, and did it while a second storm spun nearby and the Atlantic sat silent. The last time the basin did something like this, in 2004, it was the start of one of the most violent seasons on record. That does not guarantee a repeat, but it is a marker of how much heat is loaded into this ocean right now, and how early the most dangerous part of the season may be arriving. We will be tracking Mekkhala closely as it makes its turn, and we will know a great deal more by the time it reaches Okinawa. Keep an eye on the forecast if you have people or plans anywhere in southern Japan this week. And stay with us, because if this June is any indication of what the rest of the season has in store, this is a story that is only getting started.